Hey guys, and welcome back to Harry's Herpetological Adventure. I've just returned back from the first ever From the Darkness into the Light conference hosted at Drayton Manor by both Advancing Herpetological Husbandry and the BHS, British Herpetological Society. We're going to be looking through some of the talks and workshops that were given over the two-day event, because some of you guys, obviously AHH members and generally my subscribers, weren't able to make the event. In this episode, we're going to be watching Baines' talk on using environmental lighting in a captive setting.
First thing I want to ask is a question. Why do so many creatures do this? And it's not just reptiles, is it? It's pretty much everybody. And it's because we think of sunshine as something that's nice. We go outside on a nice sunny day. But sunshine isn't just something nice. It powers the entire world. It's the life on Earth is solar powered when you think about it. And it's just the whole of what that huge atomic power station out in the sky is producing, which is keeping us alive. And every habitat, whether it's a nocturnal, whether it's crepuscular, whether it's diurnal, whether it's basking, whether it's thigmothermic, all the habitats have one thing in common, which is day and night. What is sunlight? Let's have a look at what sunlight is. Now, a lot of you will know, obviously, from school, that when you split up light, it splits up into all the different wavelengths of colour, and they all blend together to make white light. And we can see the colours of the rainbow through from long, short wavelength violet right through to the longer wavelength red. But of course, there's other wavelengths that the sun puts out that we can't see. And we've got, down the very short wavelength end, we've got ultraviolet, and up the long wavelength end, we've got infrared. So scientists have divided the spectrum into by the numbers, by the actual wavelengths, by the measurements of those wavelengths. So we get something like this, which is the solar spectrum, which will run down from UVC with the very short wavelengths, 200, 250, up through UVB and UVA into what we call visible light, and then it goes off what we can see at about 750, 800 into infrared, which is short wavelengths, light produced by the sun. Short wavelength infrared. And fortunately our atmosphere cuts out the nasty stuff, which gamma rays and UVC and a little bit of the very short wavelength UVB, and it lets through everything from about 295 nanometers right through to infrared, short wavelength infrared, mind you, and that's the solar spectrum. And life makes use of every single bit of it. Life doesn't separate them out like we do in our minds, it's the whole thing. And reptiles need all of it, and they need it at the right level. Not everyone's going to need full sunlight, not everyone's going to need full shade. And it needs to be for the right length of time. We've talked about how important the photoperiods are for breeding in particular, but for the daytime as well. And so we can look at it, we can divide it up, because it's easier mentally to divide it up, into thermoregulation with warmth, and as Ron was telling us yesterday, warmth is from all of the radiation, not just the bit that we can't see, but obviously, we don't think of visible light as producing heat, but of course it does. And then we've got the visible light, which is for vision and also governs activity levels, we'll be talking about that. And then of course we've got the UV, and the one that everyone worries about is the vitamin D, the UVB. So we're going to try and cover all of those things in about 45 minutes, so it's a bit of a rush, but it's good fun. So reptiles use a gradient, as we know, a heat gradient, but there's also a light gradient from full sun into full shade, and thanks Francis for your photo. And as you can see, they're going to utilise all of it. And this is my little sketches that I produced, just to show that the gradient falls off for all the three things that we're looking at separately, as if they were one. So that in full sun, and then fading out into full shade. Thermoregulation, let's look at that for a few minutes. How does a reptile get up in the morning? Well, most of the scientists have worked out, from putting animals into thermal gradients and measuring what they like to have their body temperatures, what the optimum core body temperatures of the reptiles are. For example, for a leopard gecko, between 25 and 27. Bearded dragon, they say, well, 34 to 35. And corn snake, well, they've done a bit more research on corn snakes, and they've pointed out that when they're digesting their food, they actually prefer to have a slightly higher core temperature, and I'm sure a lot of the other reptiles do as well, but maybe they haven't looked at it so much. But when we look at the actual environment the animals are in, let's have a look at our leopard gecko, Afghanistan desert. At night it's 19, which is way different, and in summer, in the daytime, look, it's much hotter. So what's going on? Well, it's pretty obvious, isn't it? They bask to get warm. But this is what you hear all the time on the forums. They never see daylight, they're nocturnal. Well, let's just look at this. Now, this is my gargoyle gecko, and he's asleep. Can't tell because his eyes are open, but he's asleep. And there's absolutely no way that he's not in daylight. What we don't think, because we're so unused to thinking about UV, is that because UV is part of sunlight, it's also part of daylight. If he's asleep in daylight, he's getting UV all day while he sleeps. So to say that he's nocturnal, doesn't need any light, doesn't need any UV, is a bit odd. And it's the same with the shade dwellers, the ones that are thigmothermic. They're picking up the warmth from the atmosphere, but they're also picking up daylight. So they're getting UV as well. And do nocturnal animals bask? Well, that's one of my leopard geckos. I don't know what he's doing, do you? Can you guess? I think he might be basking. And I think that's because the word cathemeral comes to mind, and the more research that's done, the more we find that if we really watch these nocturnal animals, they actually come out occasionally in the daytime too, particularly when they're gravid or something like that. You'll see them actually basking. These nocturnal animals, so-called nocturnal, they're actually cathemeral, and they do come out into daylight. And to get the preferred body temperature, it's really vital, because if the body temperature is too low, all these things get depressed. Things like the heart rate, the locomotion speed. They're not so good at running away from predators, they're not so good at capturing their prey. The muscles of their gut don't work as well, so they digest much more slowly, or if at all. And likewise, all the little things that are fermenting gut, particularly in herbivores, is going to be depressed if the temperature isn't right. The immune system is depressed quite strongly if the temperature drops below the normal body temperature and growth rate slows. So it's really important to get those temperatures right. And to do that, reptiles have to find a heat source. And it has to be equal to or above the desired temperature, because you're not going to warm up if you're only just reaching the temperature you want to reach. It's going to take forever to get your temperature stabilised. So it tends to be above the desired temperature for the heat source. But of course, if the temperature is above the desired temperature, once the animal's up to temperature, it then needs to move out of that, and that's how they can do their foraging. And they'll go into cooler areas, which are heat sinks. So you've got a balance between the sources and the sinks. And the cool temperatures, or what we call the heat sinks, is absolutely normal. So we need to provide both in the range. And also, animals will adjust the temperature of their core temperature depending on their physiology. For example, if an animal's ill, it will quite often bask a lot more because it will run a temperature. It will cause itself to run a temperature, and that will help to get the immune system going and get rid of the bugs. So you have to give a good range, and you have to give a good basking temperature. Well, how does basking work? This is my bearded dragon, and this is the sunlight. We imagine there's some sunlight coming down, and we're going to look at the short wavelength infrared. We talked about the bit of visible light adding to that, and short wavelength infrared is slightly different from what we imagine because it actually penetrates the body. It goes right through, which is why if you lie in the sun, you feel really warm. You don't feel prickling hot on your skin. You just feel that your body's being warmed, and it is, because the heat is actually penetrating quite deep into the body. So with a small lizard, it will go right the way through to the internal organs, this radiation. So it's being warmed up from inside almost. But also, the short wavelength infrared will heat the ground, and the ground will then re-radiate in longer wavelengths. That's how it works. And that long wavelength stuff doesn't come from sunlight, it just comes from hot surfaces, and it doesn't penetrate the body. It lands on the surface of the skin and it's not absorbed. So what happens then is that the heat is dumped on the skin, and then it's conducted by the blood vessels and by the tissues. So it takes a lot longer to warm up, so you get the skin is hot, and then the body could be still quite cool. And of course, if it's lying on a warm surface, you've got direct conduction of heat into the body. So if we look at incandescent lamps, they're going to produce mostly short wavelength infrared, but also some of the longer wavelengths. And if we look at things like ceramic heaters and heat mats, they don't give you the short wavelength stuff, they give you the long wavelength stuff, which is, I think, one reason for we used to have a lot of problems with getting animals burned, because they'd be sitting under a ceramic heater and it would just be heating the surface of the skin, and the bigger animals are still cold inside. And of course, you've got things like heat mats, warm substrate for conduction, for direct heat. So if we look at the spectrum of the sun, this is the spectrum of the sun here, and it's right up in the shorter wavelengths. You've got the UV here, you've got the visible light, and then you've got the infrared, and you can see it tails off by about 1800, so it's all short wavelength infrared. If we then start looking at, that's the infrared in sunlight, and it penetrates the body to the deepest between these wavelengths here, the red wavelengths and the early short wavelength infrared. So that's the maximum body penetration. So let's look at our lamps and what difference we've got. If we've got a basking lamp, an ordinary halogen lamp, it's got some visible light, it's got a lot of red, and it's got a lot of short wavelength infrared. So that's going to penetrate quite a lot of the body. If we look at things like the quartz heaters, the ceramic heaters, there's very, very little in those wavelengths. It's mostly the longer stuff. And if you have a red lamp, which we talked about, Ron was talking about yesterday, you haven't got much visible light at all, which I think is a huge loss, but you have to put in some sort of bright light to make up for it. But you have got those short wavelengths again, so from a heat-only source, not for visible light, it's perhaps a better choice maybe than a ceramic heater. This is for daytime, remember, because you've got visible light. So basically short wavelength lights, more like sunlight, long wavelength infrared, more like warm soil. So I've just done that little diagram there to show those two things. Well, how warm is it? What temperatures are we looking for? This is the curious thing, which I really only discovered a few years ago, which is ridiculous because it's kind of logical. If you take the air temperature, this is a little air temperature thermometer, but you can use an ordinary probe thermometer, you'll find that the air temperature might only be, in this case, is in southern Spain, looking for little Testudo Greca with the tortoise trust. We found that the air temperature was about 27, 28. But if you take the temperature of the substrate, it's 40, so there's a huge difference. And likewise, if you take the temperature of the tortoise's carapace, it's 40, roughly 40 again. So you think, well, that's a big difference. What do I choose in my vivarium? Well, it's even worse if you go to somewhere like Kruger and you start looking at the soil temperatures there. I got 64.3. Well, how many of us would heat our substrate to 64.3? Because the air temperature is only 27, so it's the same sort of temperature. So, really, when you're checking your basking zones, really these are the tools to get, these infrared thermometers, thermal imaging cameras, because you're looking at the surface temperatures. If you stick one of these little kits that people buy for their animals, I got one the other day, a little kit for crested geckos, it was super cheap. And sure enough, they give me a couple of these and stick on the back wall. Well, I mean, it's taking the temperature of the back wall. So it's pretty useless. I don't want to know the temperature of the back wall. So, you know, I wish people would sell them with a little infrared thermometer instead of one of these sticky things. What temperatures do we actually want? Well, there's lots of information from research, lots of information from people who have written books on the subject, so obviously we need to do some research, find out what the temperature of the bodies needed to be from these studies on it, and look at the temperatures that you want to get above that and below that for the different zones. For example, bearded dragon. I love bearded dragons. You've got the body core temperature, that was what the books say, that if you put them in a gradient, that's the temperature they like to keep their bodies at. So you could put a basking zone 40 to 45 centigrade, that's great, as long as it covers the entire body of the animal, not just heating his back. And then you've got a cool zone, a heat sink, which you could have the temperature, air temperature about 24, 28, that's fine, he could shuttle between the two. But what colour is the substrate? When you're measuring it, it makes a huge difference. I went up onto the mountain in January, freezing, blooming cold, and there was still a little bit of snow on the ground, and I found some white rock and some molehill, frozen molehill. And I took the air temperature and it was 1.4. Okay, with an air temperature of 1.4, the snow was still just about freezing, but where the sun had hit it, the white rock had gone up to 10, so that's, you know, nearly 9 degrees difference. But where the soil was dark, it had got up to 17.2, so that's a really big difference. There's a difference of 6 degrees just from the colour of the surface. So it works the same way when I test my lamps. I stick little coloured blocks underneath, and if you get a black block, you can get up to 9-10 degrees difference between that and a white block. So just think about it when you're setting up your tests for your substrates. You know, you're going to get a difference if you use white sand. It might not. Your animal's dark coloured, it's going to look different. And also do remember, so if you're going to set it up, you could use a mid-brown substrate, something like wood or stone, just to check the temperatures. But also do remember that your animal might be 6 inches tall, which is 6 inches closer to the lamp, so it's going to be a lot hotter. So when you're checking your basking temperatures with a new setup, why not get a piece of wood or something like that that's at the reptile height and check the temperature there? And a lot of beginners never think of things like that. And of course, overheating is a huge risk. I always include this little bit because it's just a warning. Bird body temperature preferred is 34. Happily basks at 46, but if the air temperature went up to 46 and it couldn't get out of it and it got to that sort of temperature, it would die in 10 minutes. So you really do need to encourage all your people you're selling them to buy a thermostat. You've also got the problem with if the animal's too close or the beam is too narrow. You can see that this little sulcata is really having a big problem because the only bit that's really hot there is that little circle on his back. His little feet are probably about 10 degrees cooler, and he's not going to get, he's going to stress the shell with all that extra heat. So again, check the heat when you make up the basking area. This is some nice thermal imaging from Andy Highfield. Some of you have seen this before on the different forums. These are wild tortoises out in the sunlight. You can see the whole body is within a couple of degrees of the same temperature. Whereas if you put them under a spot lamp, you've just suddenly got this little hot patch, and the head and the feet are a great deal cooler. And that's the problem, the basking zone is too small. You can test it easily on any lamp you use. Just hold a piece of paper underneath and look for a wide beam, not a horrible little spot that's less than 5 centimetres diameter, a 10 centimetre diameter circle. That's going to be a problem for a bigger animal. There's a lovely diagram from Matt Versiweld. He's shown, just to show people, that you can get a really nice big basking spot using 2 flood lamps with a lower wattage rather than one big heavy lamp, which might not do the job. So to summarise thermoregulation, you need to research the required temperature, provide the short wavelength infrared and visible light from above, and the long wavelength from below. So you've got the basking lamps above and the heat mats and CHEs from the side or below. And then you've got to make sure the basking area is large enough to cover the whole animal. Heat gradient, and we're going to try and recreate that in the terrarium. So let's move on to vision and activity levels. I put the two together because they're all to do with visible light. So we've got the wavelengths from the ones that we can see as humans from about 400 to about 750. But of course, a lot of our reptiles can see well into the UVA, so that needs to be in the spectrum too. And the reason is really quite fun. We have 3 cones, a blue, a green and a red cone in our eyes, in the retina, and we can tell the difference between different colours by the brain working out what percentage of each cone is being stimulated. So, for example, if it was a turquoise light, all 3 cones are stimulated, the blue and green one's about the same and the red one less, and our brain goes, oh yeah, that's turquoise. Well, if we've got a turtle, for example, it's got an extra cone here, it's got a UVA sensitive cone so it can see into this range. So if the light doesn't have any of that in it, it's going to look a funny colour to the animal, even if it looks white to us. And you can see the turtle, in fact, has a much wider range than we do. It can see even into a tiny bit of infrared that we can't. And also, if you look, the peaks are slightly different positions. So when we use the RGB, you know how we have these 3 red, green and blue on, say, television sets. If you mix them up, you get a white light. To a turtle, an RGB isn't going to look white. because you can see that the peaks are different. So he's missing that one's shifted, that one's shifted. It's not going to look white. So we have got a bit of a problem getting really good white light. We need a spectrum as close as possible to sunlight. And if you take away UVA colour, just as an example, I took away red from these berries, you realise that if you take away a colour out of something, it looks weird, and you may not even be able to identify it. And lots of reptiles have UV markings. These blue markings are actually not blue, they reflect UV, so that he looks really handsome to a female. And also the foods, a lot of foods have a bluish sheen, possibly reflecting UVA. So you need to get full spectrum light. A lot of people use coloured lights, and really they are awful for colour vision, because if you have just one colour light, you lose all your colour vision apart from that one colour. And if you don't believe me, try it. So you've suddenly lost not just the UVA, you've lost everything. So please don't use those, they're really horrible. Right, so what about activity levels? Why do we need it bright? Let me show you. The brain of a reptile absorbs the light in a different way, not just visually, but also physiologically. Because the light will go through into the brain. It'll go through the eye, it'll go through, for the animals that have got one, it'll go through the parietal eye, and it'll actually go into the brain through the skull. And if you don't believe me, look at a leopard gecko, because you can see in one ear and the light comes out the other. And basically it's bathing its brain in light. And if we go into his brain, let's have a look at his brain. We've got the third eye here with light coming through. We've got the brain being bathed by light from outside and also coming through the eye. And it will send messages to the SCN, the SCN. And, sorry, I can never say that. And also there are actually receptors, deep brain receptors in the brain, which will respond to light. And all of those messages are then sent to the pineal gland, which will produce all these hormones, this neuroendocrine network, which produces the hormones and the stimulation to the SCN, which actually regulates the circadian rhythms. And it works in people too, but it works, obviously it's very important for reptiles. And you need the right intensity of light, because if the light's got to go through the skull and it's got to go through the third eye, it's got to be intense enough to mimic what's in the wild. And if we put them in sort of very dim light, then they're not getting the stimulation that they would have got in the wild. And that seems to cause problems with some species. It needs to be bright enough to stimulate the brain. How bright should it be? Well, you can measure light with a lux meter, but it's only measuring the wavelengths we can see. But it's a good idea, it's a good guide. And I did this through sunlight in South Wales in June, quite a few years ago now. And what I found was that 5 minutes after sunrise, I was getting 3,300 lux. And just before sunset, it went down to about 1,000 lux, and then of course it was gone. But over the course of the day, you can see it goes shooting up. By about 7:30 in the morning, it's well up into the 90,000, 100,000 lux. And it will go even higher, and then of course if the clouds come over, it might drop down to about 40,000 or even 4,000 at about, when it's actually raining. But if we start looking at the lamps we put on them, if you put a UV fluorescent tube on it at 12 inches away, you're only getting 480 lux. That's less than you get after sunset. And we think, oh, that'd be good, that'd be quite bright. Well, it isn't. If you put in incandescent lamps, you might get up to 12,500 lux, which is like 20 minutes after sunrise. Mercury vapour lamps, a little bit better, but the only ones you can really imitate bright sunlight with at a reasonable distance are the metal halide lamps, which is why I think they're wonderful. I just wish they could get the beams a bit wider and the UV a bit more long-lasting. But I think will happen, but they really are very, very good lamps. But if you put something like a metal halide over one end, you can see the problem with a normal indoor setting, because it's such a focal light and it's so bright, it's so glaring, that it makes the rest of the place look like pitch dark. And you've really got to illuminate the whole vivarium to get the intensity of light, even in shade, equivalent to what you'd get outdoors. And of course you'll get the gradient from heat to cool, but also from bright to less bright. and I've got a couple of setups here. You see the gradient there is from top to bottom. Those are just off the internet, I'm afraid, so I don't know whose pictures they are, otherwise I'd credit them. So we've got the heat and light gradient now. So there we are, the little light bulbs. What about this UV? Let's look at the UV. Why do all reptiles need UV? Well, to be honest, you have to say, do all reptiles need UV? Well, they all benefit from UV, because it's obviously patently obvious that people have bred them without UVB. They've been giving them vitamin D supplements very successfully, breeding quite large colonies with no UV. But it's not natural because there's masses of UV out there. So let's have a look at it. The short wavelengths make the vitamin D. You also need the warmth from the sun to make the process. And the slightly shorter wavelengths as well add to it and control the vitamin D synthesis by a self-limiting process of the biochemistry in the skin. But UV isn't just for making vitamin D, it has effects on the whole body. So let's just go through that and have a look at that. UVB. What does UVB do? Well, it has direct local effects on the skin. It's strongly bactericidal. If you put, in the World Health Organization want you to purify some drinking water, they're suggesting that you put the water, which could be contaminated with bacteria, into the sort of plastic bottles that will let UV through, lay it out in the sun for 6 hours and it's sterile, which is quite shocking. But it does mean that if we've got UV and we've got animals with perhaps some dirt or some infections or something on the skin, perhaps it's muddy water, it's come out of the pond, if it basks under UV light, it's going to clean off all those fungi and bacteria and possibly even some of the viruses. But it also affects the skin because it actually it causes immune modulation in your skin. And it stimulates your white blood cells, your lymphocytes, to come up and attack anything that might be invading. And it also stimulates your melanocytes, your pigment-forming cells, which is why we get tanned if you go out in the sun. And a lot of people will say if you give light, the correct amount of UV to your reptiles, you'll get nice beautiful colours developing because they're producing the right amount of stimulation for their cells to produce colours. In humans, I don't know if it's been shown in reptiles yet, but it's been shown in humans that UVB will stimulate endorphins in the skin, which is your feel-good factor, which is why one of the reasons why we feel so happy when we go out in the sun. The bright light also affects us and stimulates us too, so it's a combination of the bright light and the endorphins that make us all smile. And of course we've got vitamin D synthesis, so let's have a little look at that. Vitamin D is made from a cholesterol that's in the skin. The UVB transforms it to pre-D3, and the warmth transforms it to vitamin D. Vitamin D is not a vitamin. It was called a vitamin because they discovered it was in cod liver oil and they thought, oh, it's a food substance. But they now know it's not a vitamin, it's actually a hormone. And it's a very powerful hormone. In the skin, there's a local effect. The cells of the skin can turn it, they can hydroxylate it to 25-hydroxy-D3, and then another enzyme will convert it to the active hormone, which is 1,25-hydroxy-vitamin D. It's in the skin cells. And that transcribes genes, and it controls the intracellular signaling. It's really important in the skin because it adds to the antimicrobial effect by causing synthesis of these peptides which kill bacteria. It increases the barrier of the skin cells. It controls the cell division. If anyone has ever had psoriasis, you know they'll give you UV because it helps control the skin cell division, and again it affects the immune system. So basically you've got more skin health. But it doesn't stop with the skin, because the vitamin D then moves into your circulation and into your body. So it will go to the animal's liver or our liver, where it's converted that first stage to the 25-hydroxy-D. Now that's very stable. That lasts about 2 or 3 weeks in human beings. And that's the one we test for. If you have a blood sample tested for vitamin D, they're looking for this 25-hydroxy-vitamin D. And a small amount of that is needed every day to keep our calcium metabolism right. This is why we don't get rickets, why animals don't get metabolic bone disorder, if there's enough of this to be converted to that active hormone by the kidneys. And that's called an endocrine function. It's an endocrine hormone. It's under control of the parathyroid gland, the calcium and phosphorus. So that makes sure that you've got good regulation. And how it works is it enables your gut to take up the calcium, It enables the calcium to be laid down and kept in the bone. And also, of course, calcium is vital for muscle function, including your gut muscles for digestion, your reproductive muscles for expelling eggs. Growth and reproduction is vital for reproduction. You've only got to think about eggs and calcium shells. But also it's very good, it's important for fertility. There's all these new studies that show that sperm formation, egg formation require vitamin D and calcium. And that's the classic picture. And that's what I was taught at vet school. And of course, you've got vitamin D in the diet as well, adding to that, and it's all hydroxylated and forms that pathway. And that's what I was taught at vet school. That was all that was known at that point. And about 10, 15 years ago, they started to look at inside cells and what's going on. And they found that actually, that is just what you need to keep you alive. If you don't have that little pathway, you get metabolic bone disorder. And it's terrible to think that a lot of our animals get that. But if you then increase it, so you get optimal vitamin D3, better UV, better supply, what happens? Well, the first thing that happens is that you get more of the 25-hydroxy-D in your circulation. It's like a sort of bumping up the tank. But also, it increases the amount of the actual vitamin D3 in the hormone, the raw stuff that's just come through from the skin. And it only has a half-life of 1 day. So people haven't tested for it much. But what happens with that is that goes straight into the cells in almost every cell of the body. They've got vitamin D receptors that will pick up that vitamin D. And it has to be given every day because it's only got a short half-life. So you need to have your vitamin D every day. And what does it do? Well, it's transformed inside the cells into that hormone again in tiny, tiny amounts. And the cells use it up and then get rid of it. And those paracrine autocrine functions, that's the gene transcription, that's the intracellular signalling for over 2,000 genes that are affected by the vitamin D levels. So it's doing big things. And we can summarise the whole thing by saying we've got gene transcription, etc., etc., and we've got the endocrine function keeping the guts going. But we have to remember that the light and the vitamin D work together. So we've got light on the brain, creating all these hormones here inside the brain, and that's going to affect all the organs as well. Particularly, we're talking about reproduction, the gonadotropins, which affect the reproductive system. So, bright light with the right amount of vitamin D. Basically, you can summarise the whole thing. Maybe I need some more sunlight. What happens if you don't get enough? Well, metabolic bone disorder. We know it's one of the commonest conditions that's presented to vets with reptiles. And we've all seen these horrible, poor little things. And those animals are never going to recover. Those animals in the wild would have died a long time ago. But funny enough, it doesn't seem to happen in the wild, does it? And the reason is, it's virtually unknown in wild animals because UVB doesn't go through glass and it's not produced by ordinary light bulbs. So it's a disease of indoor animals. And we are indoor animals. In about 150 years ago, up to a third of the children in Britain were diagnosed with rickets, and it's coming back. That's 2010, that's 7 years ago. They said there was a huge increase in rickets in children, 20% of children. The doctor said it was reminiscent of 17th century England when they were checking for bone problems. They found it was rickets, it was early rickets. And it's quite an astonishing fact. The more research is done, they say about 70% of humans are now deficient. They've done a study here. There was 15,500 participants, and they took these samples of 25-hydroxy-D, and they found that this was the healthy level. This is when your parathyroid gland is quite happy with your levels and your calcium's doing pretty well. They found that 74% were below that level. They were clinically vitamin D insufficient. Now that's just a boring old graph. So I got my family and I made all of them prick their fingers and all have a blood test. They didn't like it. But I discovered that my husband had a UV level, a vitamin D level of 10.3, and my son was 8.8. So if he'd been a child, he would have had rickets. So it's a real thing. It really is a real thing. And we're so deficient because we've come out of the sun. In the 1800s, if you were a Caucasian living in Britain or one of these northern countries, you would have fair skin, but you'd be out all day. So the amount of skin that was exposed to the sun, you might have got 10 hours of light a day, especially in the summer. But now, I mean, do you spend more than 1 minute outside a day? I don't. It's quite terrifying. And it gets worse because we've got so frightened of the sun that we now cover ourselves from head to foot and put sun cream on, so we don't get any sun at all because, oh my God, we might get skin cancer. Or we're going to get a lot of other problems. Because if we ever get rickets and the children are starting to get it, that's an end-stage disease. All these other things with the weak muscle, the weak immune system, reduced fertility, weakened heart, weakened insulin production, reduced cancer because the cells are not responding to spotting something going wrong with the cell division. You know, we're putting ourselves at risk, and a lot of folk have autoimmune diseases now. And, you know, the immune system isn't working. Now, how much is vitamin D deficiency and how much is all the pollution? I wouldn't like to say, but I would say that if we get our vitamin D levels up, we're at least giving ourselves a bit of a chance. So how much vitamin D do humans need? Well, they used to say 400 to 600 units, and if you go to the chemists and buy some vitamin D, you'll find that they've probably got that. And that's just your bone health, that keeps your calcium going. But if you want to get the levels that primitive cultures have got, you need to have about 10 times that much. You need up to about 4,000 units a day. And I'm still pretty healthy and I don't get colds anymore. But if I was to do it out in the sun, I would need to be out for 40 minutes with my bare head and arms in June in the sunlight to create how much I would need, or even not even quite what I would need. So it's getting really difficult nowadays to get enough. But what about our animals? What about my little tennisaur, Blue? He's sitting in that window, he's not getting any UVB at all. And we have to work out how much they're going to need, because each species will regulate how much light it needs. And as we saw earlier, you know, a lot of species will lie out right in the sun, but quite a lot of species will live in the shade. I haven't got a good picture of a shade dweller there. I ought to pinch one of Francis's pictures. But animals do know. The animals self-regulate. And I wish I could find out who took that picture, because I just love that picture. Animals know how much sun they need. And the funny thing is, so do we, but we've kind of lost it. So how much sun do reptiles need? Let's get back to our topic. How can we measure the UV and what do they get in the wild? Well, we can measure the UV, as I'm sure you've all discovered during the day and even bought some. You can use a UV index meter. Well, why the UV index? It's a very simple scale. It just runs from 1 to 11 or 12 or 20 or whatever. But it's very easy to remember. It's familiar from weather forecasts. And you'll find that sensible exposure for humans is very similar to that for animals. For example, 0 to 2 is very safe. You don't get any suntan from that, but it's safe for shade dwellers. If you have 3 to 5, it's fine for us for sunbasking, it's fine for animals for basking. If you happen to take a reading and it went up to 10, that's getting a bit dangerous for us, and most animals will have long gone into shade by the time the sun's gone up to that high. And if you took a reading of UV 20 off your lamp, then that is not a solar reading. It's crazy, because the highest you'll ever get on Earth is about 16 to 17. So it just gives you an idea, it gives you a handle on it. And what UV levels depend on is really important, because if you go to a meteorological site and you look what is the climate, what is the UV, it'll give you the midday average for a clear sky. Well, of course, that's not when our animals are out. If we look at the height of the sun in the sky, the latitude and the season and the time of day, the sun comes up and there's hardly any, because the sunlight's going through a lot of atmosphere right by the horizon. And as the sun rises in the sky, the atmosphere is thinner above us, so the UV index will rise. And in Perth, Australia, for example, by about 8 o'clock in the morning, it's gone up to about 3, and then it rises up, and by midday, it's crazy, it's up to 11, and then it falls off again as the sun falls in the sky, and then you get that evening patch. Of course, if there's cloud, it blocks an awful lot. You can see this would be what would happen if it was clear sun. But then the actual reading, there was obviously quite a lot of cloud that day, and it went right down. But these are small changes, because the biggest change for animals is not just the rising of the sun in the sky. We can say, well, he's going to be out basking at this sort of time, but it's also going to be where he's basking. I did this little very simple experiment in my garden. I held up UV meter about this sort of height, you know, up in the air. So it was in clear sky, a bit like a weather station would get it, 6.7. I then started to lower it into the grass, not even foliage, just grass. And by the time I got down to about here, it's gone down to 2.9. And by the time I got it right into the grass, which a small lizard would be, it's dropped down to really low. So that's going to make a huge difference, the microhabitat, to the UV that's required. Gary Ferguson and his team in Texas, 2010, gathered up all the work they'd done for the last 4 or 5 years and produced a wonderful thing, which was basically his UV index guide, and published a paper, and we used it for the work we did with Biaza. And what he basically did was he just noticed that animals which were shade dwellers, for example, tended to be within this range, so they tended to have an average UV of around about 0 to 0.7, and then the maximum for each of those species, one species was, the maximum he ever saw was 0.6, and one, I don't know which, was 1.4. So it gives you a kind of a range for the average and the maximum. And then he went through the different, and he said, well, these bask a little bit, and then he found, well, yeah, they're slightly higher UV. It's very, very logical. And then, of course, the crazy ones that go out in the sun all day, he noticed he could record them at quite high levels. But on average, given the time that they spend in the shade and the sun and averaged out, it's actually not nearly as high. So we just said, we called these the Ferguson zones. And I unashamedly started it, and fortunately other people agreed with me that he should have the honour for it because he'd done all this work. And we then launched the UV Tool project, and we had 13 different zoos working on it. It was something I was really excited to be involved with, and we put together this guide, which has been published. It was published last January. You can read it, it's free access on the internet. And we've got 256 species, roughly assigned into one of the 4 zones. It's a very crude thing, but it just gives you a handle on it. And then we said, well, okay, we'll take the pet species, and we'll say, well, are they crepuscular, or are they open or partial sun? And so we've kind of got little categories here. You can see we've put things that we know live in the shade, and then things we know that live in the hot sun, and we've put them into these groups. And you can say that that's like the all-day average. So for the shade dwellers, it's like shade. So we could say that the shade dwellers could have that sort of range of UV. It's very, very crude. These are the sort of areas that you can talk about. You can say, well, would they be top end of that or bottom end of that? You know, maybe this one would need more than that one. It's just debatable. It's all an approximation. It's just to give people a handle on it. And then we said, well, what about the sun baskers in the sun patch? In the sun patch, which is like sunlight, we could give them up to the maximum. So if they're partial sun baskers, they might like up to UV index 3, might get that in a forest, in a glade. And then if it's a midday basker, and we capped it at about 8, we said, we're not sure with the artificial lighting if it's actually safe above about 8, because you've got a lot of other things in artificial light, the spectrum isn't quite right. So we capped it at 8 as a safety feature, but most of them will be wanting about 3 to 5, because that's a good sort of morning UV. So then we said, well, how do you choose a UV lamp using that? Well, it's very good because UV lamps come in 2 types. You've got the fluorescent tubes and compact lamps, which is a low output, unfocused type of beam, which is, whoops, what's happened now? Oh, that's right, which is like shade. So we could use this for our shade dwellers. And then we've got the high output lamps, the mercury vapours, the UVB halides, and now the T5 high output tubes. And that's more like a sunbeam, so you can create more like a sunbeam with those. So we can use those types of lamp to give people a handle on that. So I discovered quite a few years ago that I could do these funny things, spending hours and hours being really nerdy, plotting UV gradients. And some of you will have seen the ones I've plotted out at the back. And I discovered that things like your D3 plus T8, the old-fashioned fat tubes, we used to say you had to get them within 6 to 8 inches of them, and it's true, because if you want something like a UV index 3 for a sun basket with that lamp, it's got to be like 10 centimetres away, which is crazy. And a little tortoise, for example, at 30 centimetres, at a foot away, it's only getting about a UV index of 1 to 1.5. So obviously that tube would not be what you'd choose for that species, but it would be really good for a gecko. For a sail leopard gecko, you want UV index 0.5 to 1. So if it's about 30 to 40 centimetres away, you've got a good tube. Likewise, if you want a little bit more, put a reflector on it. And if you have a T8 tube with a reflector, it approximately doubles it. If you have a T5 tube, it trebles it. So you can boost it a bit. That was the same tube, except with a reflector on it. It's still light shade, but it's boosted it a bit. So it's still 20 to 25 centimetres. You're getting more like UV index 2 or 3. So for an animal that basks a little bit, that one might be quite useful. And again, you've got the compact lamps. Compact lamps are greatly misused. They are absolutely useless for a basking species because the amount of UV they put out is in such a small area, and it's so intense when you get up close that it's very difficult to get a good gradient. But they're really good for the shade dwellers in those little exoterra things, because you put them above the mesh, and that little area just underneath the mesh is great for an occasional basker. So that's what the sort of thing you'd use those for. And then what about the sunbeams? Well, the metal halide lamps are brilliant for light, but the beam is quite narrow, but you do get high UV indexes in the beam. So at 30 centimetres, you're getting UV index 6. So yeah, that's a pretty hot lamp, but it's kind of narrow, and I'm hoping they'll improve that over the years. But if you use a mercury vapour lamp, be very careful what short you use. This is an Arcadia one, and if you look at my display over there, you'll see there's three basic ways that they make them. There's the ones that are completely diffused, like an opal colour, opal on the front, and they will diffuse the beam like that. They'll make a very wide beam, very hot, but you can use them for basking very nicely. Then there's ones that look, the par 38 ones, which are sort of slightly milky or clear, and they have a narrower beam. And then there's the ones that I think are absolutely lethal, which are the ones which have completely clear glass faces, and they're the cheap ones from China, and they make a beam that's like a pencil with 1,000 microwatts of UV in that one little spot, and they're horrible. So just be careful with mercury vapour lamps if you're going to choose one. And then the ones that I really like now, I think they're the best invention we could have possibly had, which is the T5 high output tubes. They're now being used very widely in all the zoos, and people are finding them really successful. And there's one brand, which is Arcadia, and you know, if I made a penny for every Arcadia I've sold, I've recommended I would be really a millionaire, because they've turned out brilliantly. They really are fabulous little products. And soon the Zoom Med will be the same. And they've got this huge beam, and they're very, very long lasting. They last over a year. And you can make this massive area for quite a big animal at about 30-35 centimetres. You've got really like sunlight with that one little 24-watt tube. So that kind of sums up that. So we've got light, heat and UV. There's your heat, your light and your UV. And again, you've got this gradient, but there's just one thing we haven't mentioned, and that is the humidity gradient, because that's really important for a lot of species. If you don't actually do anything with sprays and whatever, you'll find that underneath a lamp that's emitting heat and infrared, it will dry the areas. That's how it works. It's absorbed by the water vapour, and the humidity will fall. So you'll naturally get a humidity gradient forming under your basking lamp, which is really useful as long as you keep this bit moist so they can get into the humidity. So when you actually do the lamps, you've got to work out that there's got to be a cool area with the right humidity. And this is just a little diagram. It's very bare, there's no furnishings because it's just to show the light. Again, it's one of Matt's ones from America, just to show you the way that you could create a really nice big basking zone using a combination of lamps. He's got a T5 lamp, he's got halogens for the warmth and infrared, and he's got a metal halide, not necessarily one that emits UV at all. You can get them for showrooms and things like that for humans. Lovely bright light, look for a good daylight one. And you've got a lovely big bright basking zone. You might want to light up the other side of the tank to get your extra visible light. To finish off with, I've just got some examples to show you. For example, very bare, I want to really improve on this, but this is just a leopard gecko setup with a little T8 tube. And if you put an overlay on it to show you what the UV is like, Obviously, leopard geckos can't fly or climb, so he's not going to get too much. He's going to get about the right amount if he climbs around. And he'll probably stay in his hide, and he'll probably stick his tail out in the daytime. Or if he's feeling like it, like mine do, if I go in to feed the others, all the leopard geckos, they pop their little heads out, getting a little bit of UV during the day. Things like Chuck Wallow's basking species, you've got a bigger vivarium, you can put something like a mercury vapour lamp in, you can get a nice gradient over where the basking area is. Or you can use, this is my Tenasaur, you can actually use one of the T5s, that's only a 25 watt lamp, and I've got the basking lamps and the metal halide to keep the rest of it warm, and you've got the massive gradient here, and he's got about UV index 3, 4, 5 if he sits up underneath that. That just gives you an idea. But then let's have a look at some zoos, because the zoos have been absolutely pioneering in this. We heard this morning from what they're doing at Paynton. And this is at London. They've put up one of these super zoos which has got six T5 tubes. And if we look at the gradient on that, you've got a much bigger spread, of course, because you've got 6 of them. So you've got a UV index of 3, 4, 5 where the Komodo dragon will be. And they've put at Chester, they've got one in their tropical realm on a kind of a table, so that the animals can walk underneath. And again, you've got this gradient which you can plot. I don't plot those there, I plot those on a wall, but then it applies the same. So the animals are walking into a gradient of about 2, 3, 4 just underneath there. I haven't got maps for all of these. Bristol Zoo have got one for their Uromastics. Crocodiles of the world are using them for their Nile crocodiles. Look at them all hiding under there. And Chester have got them for their Komodos. And they've also used putting perhaps just one UV tube and all the rest daylight. In the light waves, they take up to 8 tubes, so you can put like one UV one and all the rest light for something like amphibians, which just want bright light at the top. Just a little bit of UV to make up the low level. And the biggest one of all that I've done so far, which we're going to hopefully do some more at different zoos, I'm working on one now, possibly using the one at Paynton. But at London we've got this fabulous thing which has got 24 tubes over the Galapagos tortoises, and you can see it's about 6 feet up in the air. And I measured the UV gradient on the ground, and this is the footprint of it, so this is looking down on it from above, as it were. Here are the 4 units in the middle. They've got 2 heaters either side. They're going to replace those eventually with infrared ones, but they're using ceramics at the moment. And you've actually got a UV index of 3 across an oval 4 metres wide. So that's masses of UV. I mean, think we couldn't have done that years ago, but the animals can walk into this little fake patch of sunlight, big enough for Galapagos tortoises. So we can fix this, we can do it, we can now improve what we used to live with. We used to think this was really a good setup, and really now it isn't. I've got a shameless advertisement before I finish. I've had a huge success with breeding my little colony of blue spiny lizards, and they're free to good homes. If anyone would like some, I've just hatched out a whole load more. So if anyone wants to see me afterwards, please. I don't know what to do with them all. So thank you for listening.
I'd like to say thank you very much for watching, guys. There were some great talks at the event. I hope you do check out the Advancing Herpetological Husbandry Facebook page. The link is in the description. Otherwise, make sure to subscribe and check out the rest of this playlist for all the other talks from this event. As I said, I hope you do subscribe to check out the rest of my videos, as we've got some cool stuff coming up, especially when I get into the swing of things, because summer's coming right up. Thank you very much for watching, guys, and I'll see you on the next talk. Goodbye.